My dear students, today we shall start the design of shear reinforcement. So, let us assume the shear force of the beam is 150 kilonewton. Now, we need to calculate tau v, and you know that tau v equals v by bd, and v is our shear force. So, let us insert the symbol tau . Tau v now tau v is equal to v by bd. So v is 150 by b into d. So let us apply one bracket, and b equals width of the beam multiplied by effective depth d. Bracket close, enter. So this is our tau v, and you know that the amount of shear reinforcement depends upon the percentage of steel, and we have to follow the table 19 to calculate the design shear reinforcement. To calculate the design shear strength of concrete, which is depends upon percent of steel, PT is equal to 100 AST by BD. For different grade of concrete, we have different value of tau c for different percentage of steel. And now we need to insert this table into the Excel sheet. This is the table 19, and this is grade of concrete, this is percentage of steel, and all those are tau c value. Now we have to write a program that which can calculate the particular tau c for our grade of concrete and for our percentage of steel. So first of all, we need to calculate percentage of steel. Now just insert one row above this tau v, right click at this point and hit the insert option. You can see one row is inserted. Now PT, percentage of steel, equals 100 ST by BD. So 100 ST by BD. Now 100 multiplied by total ST, and at this position select B multiplied by effective depth D and press enter. So this is our PT value 1.78, but for this PT and our grade of concrete is M35. Our grade of concrete is M35. So for M35 grade of concrete, let us change the grade of concrete 25. So our 25 grade of concrete and for PT 1.75, we need to calculate the tau c value. So 1.75 will lie, okay, 1.75 is there, no issue, but it is not exactly 1.75. You can see this is 1.7477. For this will lie below 1.5 and above 1.75 at this position, and for M25 grade of concrete the value should be greater than 0.74 and less than 0.78. Now we have to calculate this value at this cell. Now this cell, press equal sign, go to sheet 1 and select PT value, press enter. That you can link the PT value with that cell. Now you have to write a program that can choose only 1.5 that value here. So already you know that how to do it. Press equal. Now the 1.5 is the highest value of those value which are less than 1.75. Now we need max function, max, and if function. The logic test, I want two parentheses for different condition. One is logic test, another is for true value. The logic test is this table less than this value, and here the true value is select this table. After that, what to do? You don't press the enter directly, press Ctrl Shift and enter. You can see the actual value is here 1.5. Now equal. Now we need mean function, mean if bracket open close, bracket open close, comma, bracket open close. One is for logic test, another is for true value. The logic test is this table, select this table, and greater than this value, and the true value is select this column, and now press Ctrl Shift enter. Now you can see 1.5 and 1.75 are there. Now for different grade of concrete we have different value. How we can write the program that the Excel file will automatically choose the particular value for different type of concrete. Now try to understand the function that we need. The lookup function for this case equal v lookup so lookup value comma table array comma column index comma 0 for exact match. Now lookup value is this, and table array should be this table, this table, this is the table array. Now column index, we can press any particular number of column. This is first column, second column, third column, fourth column, fifth column, and sixth column. Obviously we have fourth column up to. seventh column. So now we can't provide any particular number of column. Why? Because we have different column for different grade of concrete. So now we need some function here which can tell to this function that should be the column index. Now what we can do, we can just provide the function indirectly. That means select any cell. Suppose let us try this cell. So this cell will be the actual column index, and press enter. So no value is there. If I press 2, you can see the value is 0.68. Why? The 2 means this is the second column, and for 1.5 pt the tau c value is 0.68. Now we need to change this function, this number dynamically. Now let us insert a row at this position and put the column number. Total number of column is 7. Now apply the h lookup function. Lookup value should be our grade of concrete. This is our concrete grade. Now don't go to sheet 2 directly. You have to type comma and then you can go. Otherwise the sheet 1 will change into sheet 2. Now the table array is this. This is the table array, and row index is second. From second row we want to choose our value, that is column number, comma 0, enter. You can see our grade of concrete is 25 and grade of concrete 25 lies on column number 4, and that's why here the number is 4. And for percentage of steel 1.5 for 25 grade concrete, the tau c is 0.74. If I change the grade of concrete to 30, then this is automatically changed to 5, and you can see for 1.5 pt the tau c is 0.7, for 1.75 this is also changed, the tau c value 0.8. You can see. Now for this case also the same function will be applicable. Just let me copy this function, press escape and double click here and press Ctrl V. Now you need to change the lookup value, that is B52. So here it should be B52 and press enter. For 1.75 the value is 0.78. You can see the value is 0.78 for 25 grade of concrete. Now we need the interpolation. Previously we have done this and that's why you can copy this formula here from here, Ctrl C, select this cell and press enter. You can see total formula is copied here with our actual value. So this is our tau C. Now tau C equal this. The next procedure is we need to check whether tau V is greater than tau C or less than tau C. So tau C is our design shear strength of concrete. If our design shear strength of concrete is greater than our applied shear stress, then we don't need to apply shear reinforcement. We have to follow the guideline of IS code, that is, we can provide the minimum shear reinforcement. Here I have done a mistake, that is, I have to multiply with 10 to the power 3 here. Now you can see tau V is greater than tau C. Now you need to apply the shear reinforcement. Let us change it. So now we are going to apply the condition equal if bracket comma bracket comma bracket, one for logic test, another for true value, another for false value. So logic test is if tau C is greater than tau V, then in this cell will show the greater than sign, and otherwise it will show the less than sign. And this is tau V. So tau C is less than tau V. So here we are applying the condition, that is, if tau C is greater, if tau C is less than tau V, then we need shear reinforcement, otherwise we have to follow the minimum shear reinforcement guideline. So equal if bracket logic test comma true value comma false value, if this cell equal less than sign, then it will show that shear reinforcement is required. Otherwise it will show only minimum reinforcement is required. Only minimum shear reinforcement is required. So you can see shear reinforcement is required for this case. If I put a value which is very low, suppose 40, then you can see that only minimum shear reinforcement is required. Why? Because tau c is greater than tau v. Let us change the value 150. Now you have to follow the formula for shear reinforcement. This is the formula for vertical stirrup. You need to calculate only SV, that means spacing between stirrups, spacing between legs. Y is our grade of steel, ASV is area of shear reinforcement, D is effective depth, and VUS is nothing but V minus tau CBD. So SV equals 0.87 Fy ASVD by V minus tau CBD. Now spacing SV now the spacing of the stirrup equals to 0.87 Fy ASVBD by V minus tau CBD. Here 0.87 into Fy, our Fy is this, into D means effective depth, into ASV. ASV means area of the diameter of stirrup, and we are using two-legged stirrup, that's why you have to multiply it by 2 into area of diameter of stirrup, ASV. This is equal to pi by 4 into d square. So pi by 4 into d square, pi bracket by 4 multiplied by 8 into 8, that is dia of stirrup. And here V minus tau CBD. V is shear force, E2 into 10 caret 3 minus tau c into BD. Tau c multiplied by D multiplied by B. So 0.87 Fy ASV into D by VU minus tau C BD. Press enter. So this is the spacing in millimeter. Now design of shear reinforcement is complete for that case. Now if tau c is less than tau v, that means if this force, shear force, is very low, now you have to apply only minimum shear reinforcement, and for this case you need to change this formula again. So we have to apply another condition for minimum shear reinforcement. The equation for minimum shear reinforcement is, this is the minimum shear reinforcement formula, and here you have to calculate SV. So SV equals 0.87 Fy ASV by 0.4 B. So now you have to apply this formula. but this formula will work only when tau c is greater than tau v. That's why we need a if function. If bracket open bracket for logic test, and we can keep this formula in true value, comma, bracket for false value, bracket close. So this is the logic test, this is true value and this is false value. In the false value we have to place the formula for minimum shear reinforcement. Now logic test is when this cell will be equal to less than sign. When this cell will be equal to less than sign, then this formula will work, that is the true value, and if it is not, that means if it is greater than sign for this case, then this formula will work. So this formula will be (0.87 into Fy into ASB, that means 2 into pi by 4 into d square, pi by 4, sorry, this will be multiplied by d square, d into d. 0.87 Fy ASB by 0.4 into B. Now press enter. So for this case, the spacing for shear reinforcement is 302.47, and if we apply greater value of shear force, then the shear reinforcement is required and the spacing is this. Now you have to check another point, that is tau c max, and tau c max is provided in IS 456 table 20. This is the tau c max value, and you have to check that tau v should not be greater than tau c max. So equal, you can press this tau c max, and the greater value and the tau c max value will be, and the tau c max value is depends upon grade of concrete. So we need H lookup function to choose the appropriate value for particular grade of concrete, and after that we can go for check. So if logic test, comma, true value, comma, false value, logic test will be if this value is less than bracket. Now you have to apply each lookup function. Each lookup bracket. The lookup value is grade of concrete, and table array, go to sheet 2, and this is the table array, comma, row index will be 2, comma 0, and the true value will be less than sign, and the false value will be greater than sign. Press enter. You can see tau v is less than tau c max, so it's okay. Now you apply another function. If this cell value equals less than, hence this cell will show you okay, otherwise not okay. Now our shear reinforcement design is complete. Now I want to show you another function. For grade of steel, generally we use Fe415 or Fe500 or Fe550 like that. So how we can apply Fe in this cell? If you directly put Fe, then the Excel cannot calculate the grade of steel. So you have to go for another method. In this number pad, click on this arrow, that is number format. Go to custom, and here type double quote Fe double quote space triple hash. You can see the sample is Fe415. Now click OK. Now it is quite good that we are choosing Fe500 or Fe415 like that. And you can also apply this function for grade of concrete. Go to number format, go to custom, and here double quote M double quote space triple hash. Type OK. Now this is M20 or M15 like that. You can see. So now our design is complete. Also we need some modification, because for grade of concrete greater than M40 or for PT less than 1 or for PT greater than 3, we need another function. In the next video we shall discuss about that. Thank you.